Okay, in 5.3 we look at factoring polynomials, and factoring polynomials is like sort of undoing distribution that we used to do when we would multiply before. And what we do is we take the polynomial and we break it up as a product of simpler polynomials. So maybe if we can break it up as a monomial and a polynomial, or sometimes a binomial or a binomial, and so forth. So the first thing we look at is greatest common factor. So let's take a look at these three examples and factor out the greatest common factor, or the GCF. In other words, look at the two terms. These are all binomials, what I'm giving you. Here's the first term, here's the second term. And look at the two and see what is divisible by both, what they both have in common. And it looks like the first term has a 2 in it as a factor, and the second term has a 2 in it. So you pull out the 2, and when you factor it out or undistribute it, or undoing the distribution, it's like you're dividing it, because distribution is multiplying. So when you pull it out or factor it out, you're dividing. So 2x divided by 2, 2 divided by 2 is just 1, and then the x remains, plus 6 divided by 2 is 3, and we're done. You could check back your work by distributing. Same thing here. I got the first term, I got the second term. They both have a 2 in common, but not only 2, they also share an x in common. So I pull out 2x, and that leaves me with only 1x in the first spot, plus 6 divided by 2 is 3, and x divided by x is gone, so I have x plus 3 left. Again, I can distribute and check my work. Next one, again, I have two terms, and they both definitely have a 2 in common. They both definitely have an x in common, and I always pull out the smallest power of the variable that they have in common. And they both have a y in common, so I'm left with the 2 is gone, one of the x's is gone, one x is left. The y is gone outside. In other words, you're dividing it out by 2 and by x and by y, and you only have 1x left. Plus, the only thing left here is 6 divided by 2, which is 3. X and y are pulled out. Okay, still we're going to factor, and we're going to factor the GCF as before, and let's look at the next two. I have three terms, a trinomial. They're all divisible as far as the numbers are concerned by 5, and then they all have an n in common, and the smallest power of n is 1, so that's what they have in common. Once I pull that out, 5 is pulled out, one of the n's is gone. Out of the 4, I still have n cubed left, plus 10 divided by 5 is 2. I had two n's, one of them is out, one of them still stays, minus 25 divided by 5 is 5, and there was only one n, and the n got pulled out, so we're done. This is a monomial times a trinomial, and I took the original trinomial and I broke it up into two pieces. Next one again is a trinomial. There's three terms, but I want to point out that it starts off with a negative. Whenever it starts off with a negative, the common thing is to pull that negative outside. So between the 4, the 6, and the 8, they have a 2 in common, and I'm going to pull out, actually, I'm going to make that bold, a negative 2. So if it starts off with a negative, it's common to pull that negative and put it outside. Now as far as the m's are concerned, m squared, m, and m, so lowest power of m in common is m. As far as the n's are concerned, n cubed, n squared, n, so the lowest power of n is n to the 1. That must be my GCF, or greatest common factor. Now be careful, when you pull out a negative, it switches all of these signs to the opposite. So negative 4 divided by negative 2 is a positive 2. I have one m left and an n squared. This negative switches into a positive. I have 6 divided by 2, which is 3. The m is gone, and I only have one n left. And again, negative 8 divided by negative 2 is a positive 4. M is out, n is out outside. I am done. That's all I can do with that one. Okay, one more of these to look at. I have a trinomial. There's three terms, and it looks like as far as the numbers concerned, they're all divisible by 11, but pay attention, we're dealing with a negative that it's starting with, so I'm going to be pulling out a negative. That's going to be a negative 11. Again, I'm pulling out a negative. And as far as the x's they have in common, there's an x to the power 1 that they have in common. That's the smallest one. And as far as the y's are concerned, they have in common a y, and smallest power is 1. Once I pull that out, or divide that out, I have negative 22 divided by negative 11, which is a positive 2. x cubed, one of them is gone, so x squared is left. This y is already gone, it's out. This plus sign switches into a minus because positive divided by negative is a negative. So 55 divided by negative 11 is a negative 5. The x is gone and I have 1y left inside. Then I have negative 11 divided by a negative 11. Be careful here, that's a positive 1. X is already pulled out, y is already pulled out. I have to hold that place for it. So in the last term, what I have left is a positive 1 so that I can preserve this trinomial when I distribute it back. So if you pull the whole thing out, make sure you leave a 1 in its place. Okay, next one, factor the polynomial again. We're going to look at the first one, which looks like a binomial. I have two terms, and they don't have, the 2 and the 3 don't have anything in common. This one doesn't have an x, but this one does. The only thing they have in common is that y. So I pull out the y and I'm left with 2x plus 3, and that's the best I can do. I have a product of a monomial and a binomial. I have that thing factored. And there's no common things left inside the parentheses either. Now look at part B. It looks a little bit strange because you almost feel like distributing the 2x and the 3. But don't do that because the problem says factor. So we're supposed to break it apart and write it as a product. If you distribute, you're just going to mess things up again. Now this, B, is really very similar to A, except that instead of having a y in common, there's this giant A plus B that's acting like my y. So these two terms have a giant A plus B in common. Just like this had a nice little y in common, these guys have an A plus B in common. So I'm just going to yank that out and pull the A plus B outside. When I take out the A plus B and I put it outside, just like I put the y outside here, I'm going to be left with only 2x in the first spot plus only 3 in the second spot. So A plus B was a greatest common factor that they both shared. I pulled it out and I put it outside, even though it looked ugly and it was a binomial in itself and not just a monomial like the y. So this is my factored form because I have a product of two binomials with no thing in common in this binomial and nothing in common in this binomial. Similarly, if you look at part C, well, they have some giant binomial in common again. Both terms share the x plus 5 in common, so I'm going to put the x plus 5 GCF outside. And then once that gets divided out, in the first spot I only have a 2x left, in the second spot I only have a 3 left. And there are my two binomials. So A, B, and C are all very similar, you guys. Here, only the y they had in common. Here, only the A plus B they had in common. Here, only the x plus 5 they have in common. What was left over was always the same, 2x plus 3. Part D is similar. There's two terms. These giant binomials is what they have in common. So I'm going to pull the giant binomial, leave it outside, and what I'm going to be left with is 7x and the minus 3. Now for all of these, when I factor them, you guys, the order doesn't matter. I could have it like this, or I could have it like that. The order of your parentheses and your terms don't matter, so which one you put first, which one you put second, doesn't matter. They're all equivalent because the order in which we multiply doesn't matter. Okay, the last idea here is factoring by grouping, and grouping usually involves 4 terms. You're not going to see a trinomial, you're going to see something longer with 4 terms. And our first step is look at 2 at a time, so 2 and 2, and look at each and pull out the GCF. Then the second step is look at the big picture and you'll see a big binomial in common, and that's what you want to pull out in your second step as the GCF. So let's look at this 4-term expression and let's try to factor it by grouping. We're going to look at 2 at a time, first 2 and second 2. The GCF for the first 2 is an x squared. That's the only thing they have in common. When I pull that out, I'm left with 4x plus just a 3. Now, carry the big plus. I'm making it bold for a reason. Look at the next 2 terms. The only thing they have in common is a 2, it looks like. And when I pull out the 2, I'm left with a 4x plus a 6 divided by 2, 3. Now here's what I mean about look at the big binomial they have in common. Now these two giant binomials, the expression has in common, so we're going to pull that out and put it outside. And then we're left with these two guys for my next binomial, x squared plus 2. So I have a product of two binomials with no common factors inside the first one, no common factors inside the second one, so this expression must be fully factored. Okay, part B, again, I have 4 terms. So I'm going to look at first two guys, second two guys. Sometimes if the GCF for the first two and the second two don't work, you can always rearrange them and reorder them and put them the first and the third together and the second and the fourth together and so forth. But I'm always up for just trying the first two and the second two to see what'll happen, hoping that would work. So the GCF here is an x squared, and I'll be left with, it looks like, just a 2x minus 3 in my first expression. And then I bring down the plus sign. And notice the second expression here, the second piece has no other GCF but a 1. So if you can't pull anything out, you can always say, well, I'm pulling out a 1 as the GCF, just to keep things in order. So all I did was I said 2 and 3 don't have anything in common. They both don't have x's, so I'm going to factor out a 1. Now I can see that they have the big binomial 2x minus 3 in common, and I can factor that out and pull it outside, 2x minus 3, and then I'll be left with these two guys, x squared plus 1 for my second binomial. Okay, let's look at part C. Again, 4 terms, so I'm going to try grouping 2 at a time. First two have a GCF of x squared. I will be left with an x in the first spot and a minus 3 in the second spot. Now be careful, because remember what we said about things starting off with negatives. We're actually going to pull that negative out. I'll make it bold, and that'll be a negative 5 I'm going to pull out of the 2. That's going to leave me with negative 5 divided by negative 5, which is a positive 1, x, and then positive 15 divided by negative 5 is actually a minus 3. So the signs switched. Now I have the big binomial x minus 3 that they both have in common. That's going to be pulled out as the GCF, and I got left in the second binomial x squared minus 5. Okay, let's look at part D. I have 4 terms, so I'm going to group 2 at a time. First two look like they have a 3 in common and an x squared. That's going to leave me with an x minus 5, it looks like. Then be careful, the middle sign here is a negative, so you're going to be pulling that negative out. 4 and 10 are both divisible by 2. That seems to be the GCF. So then I have negative 4 divided by a negative 2, which is a positive 2, and the x is still left over. Then I have positive 10 divided by negative 2, which is a minus 5. Ooh, I did this wrong, you guys. When I take out a 3x squared, I actually have a 2 left over there. I noticed that because the two parentheses weren't matching up. So that's possible, you know, if they don't match up, that's either not factorable, or maybe you'll have to reorder your terms and look at 2 different ones paired up together. But in this case, I had just forgotten that 6 divided by 3 is a 2. Now I have the giant binomial that they both have in common. So I'm going to pull that out as 2x minus 5. And once that gets pulled out, I have left over 3x squared minus 2 as my next binomial. And that's the whole thing factored out.